Again, a critical number or a function has a critical number or critical numbers coming from two possible sources. It may have from one and not from the other. It may have from both, or it may not have at all. So where do they come from? From f prime of x equals 0, and these solutions, x equals whatever, let's say a number, that is a critical number. If this equation has no solutions, the function has no critical numbers coming from this source. Second possibility, for f prime of x to be undefined, but not everywhere, at x values, values, where f of x exists, or we say is defined. Why are these important? Why are critical numbers important? Only critical numbers can turn into max-min. So, potentially, and we'll explain when and what happens. If a function has no critical numbers, it will not have max-min. If it has critical numbers, there is hope for max-min. Okay, and I would like to illustrate with another problem. We illustrated with a polynomial function last time. Let's illustrate and find critical numbers for f of x equals x, e to 4x. So when I assign homework from this section and the next, so from 3.1 and 3.2, if the problem says to graph, please don't. We are not ready to graph anything yet in 3.1 and 3.2. Do not graph. Just do anything else is required, but please don't graph. We do not know how to at this point. Moving on, explaining more and more, or looking at these two sections, and then in the next section we will be able to graph. But no, in 3.1 and 3.2, do not waste your time. We are not ready to graph anything. Okay, so here the question, yes, I'm ready.
Oh, sorry. Is that an XE? Or is that...
Yes, I'm sorry.
Okay. I couldn't tell if you were crossing out something or not.
No, I'm sorry.
It's all good.
So it's x times e to 4x. So the question here is asking us to find critical numbers. That's number one. And number two are, if they exist, of course, are they extrema? This means either max or min. In general, we say extrema, points of extrema. So we are given a function and we're asked two questions. Number one, find critical numbers if it has any. And if you find critical numbers, do they turn into max-min? Okay. Before we address this problem, I need to explain something. And I'll come back to it. Please stop me anytime. If you need more time to copy, if you have any questions, you know you can always, please, always stop me. Okay. Let's take a look at this graph. This is the graph of a function. Smooth, continuous, differentiable everywhere. No cusps, no corners, no vertical tangents. We know that. So f is continuous plus differentiable everywhere. Okay, I'm going to choose a few points on the graph and draw the tangents at those points. And I have a question now. what gives the slope of the tangent line at these points. Same thing. Gives the instantaneous rate of change at these points. What?
Wouldn't that be the derivative of the function?
Yes! 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 Ah, thank you very much. Exactly. So now let's look at the function. What type of slope is this? So when I ask what type of slope, I would like you to tell me positive, negative, zero, or undefined. These are all possibilities for the slope of a line. If it's zero, it's like this, horizontal. If the slope is undefined, it must be vertical. If it's positive and negative, we know how it looks like. So I just want the sign of this slope, of this tangent.
Would it be positive?
Brilliant. Because it looks like this.
I was going to say it's that far right leading edge, right? Like wherever that line
No,
goes.
because
like,
it's increasing from left to right. Anything that is increasing from left to right has a positive slope for a line.
right, but that right side of the line where that arrow goes, it's facing.
It has
up,
nothing
right?
to do with the arrows. Nothing to do with the arrows.
Or in behavior.
Nothing to do with end behavior.
Okay.
It can do this. It doesn't mean anything. It's the slope of this line is positive because the line is like this and not like this. Has nothing to do with the end behavior, where the function is going or anything else. What is the slope of this line? I just need positive, negative, zero, or undefined.
Still positive.
Excellent. Very good. What about the slope of this line?
0.
Excellent. What about the slope of this line? Not what it is, but just the sign.
Negative.
Excellent. What about this? Of course, you know the drill. Excellent, excellent, excellent. So, can I say that this is a maximum? It's called a relative max. I'll explain a little bit more about relative, but it's called relative. Look what happens. The slope, and the slope. This is characteristic for a maximum. Positive, then zero, and then negative. But what about for a minimum? Negative slope, in other words, negative derivative, zero derivative, and positive derivative. So remember, positive derivative, zero derivative, negative derivative, relative max. A relative min, negative derivative, zero derivative, positive derivative. There is one more case, not just this. I can also have a situation of this kind. Oh, you can say cusp. Ooh, not differentiable at this point because the slope is positive here and the slope is negative here. But the function is defined. The derivative is not defined. And this will still be positive, but undefined and negative. So this will still be a relative max. So it's not only positive, zero, negative, but also positive undefined negative. That gives us a relative max. And yes, the same thing with the relative min. Negative derivative, undefined derivative, and positive derivative will still give us a relative min. But if there is no sign change, so for example, if the function has a critical number, but the sign never changes. So here, this could be a critical number, but look, the derivative has only positive sign. This, of course, is not an extrema or point of extrema. It's not, because the derivative does not change sign. Also, I want to explain something else. See, when the derivative is positive, what does the function do? Increase or decrease? When the derivative is positive, what does increases always? When the derivative is negative, what does the function do?
Decrease.
Yes. So the derivative is big. Big news for the function. Why? What do I learn? First of all, I learn when the function is increasing because the derivative is positive. I learn where the function is decreasing because the derivative is negative. And also, if there is a sign change of the derivative, I get a maximum or potentially a minimum. So two things, and I'm going to write this down and then go back to the problem at hand. Okay. I want to write.
A quick question.
Yes, anything.
What is the GIFF? What does that mean?
Differentiable.
Different. Oh, okay. Differentiable.
So, max, negative, 0, I'm sorry, positive 0, negative, or positive undefined negative. So this is for the first derivative, these two, f prime of x. So these are two possibilities for a maximum. If the derivative f prime is everything here is about the derivative. Positive 0, negative, it's a relative max. Let me write relative max. And positive undefined negative, relative max. What about the relative min? Exactly the reverse. Everything the same, but reverse the order. So, negative 0 positive or negative undefined positive. But of course, the point has to exist. If the point does not exist, then... So this is for everything here, actually, is for f prime. Also, when f prime of x is positive, f is increasing. When f prime of x is negative, f is decreasing. So this is what we learn. So f prime, this is what we learn from the derivative, first derivative about the function. A lot. Increasing, decreasing intervals, and relative max, relative min. Okay, so now we are ready to look at that problem. Which problem? This one. So I'm going to copy it again. X e to 4x. So the first question is critical numbers. Yes or no? If the answer is no, second part has no meaning. If it has no critical numbers, you cannot have max min. Okay, how do I find whether the function has critical numbers or not? I have to find the derivative. And of course, I start with a domain. So I find the derivative, I set it equal to 0. The same derivative, if it's undefined, then I will analyze the situation. Well, can anyone give us a domain of this function so we can establish that from the beginning?
All reals.
Absolutely. Exponential function is friendly. Friendly, I don't worry about it, ever. And x in front is polynomial friendly also. Perfect. So now let's find f prime of x. Which rule we apply here? Anyone?
The log rules.
We are differentiating. We are not solving equations. Look at the function and say, oh,
is the product rule.
Exactly. Very good. Function 1, function 2. Awesome. Remember the rule. If you don't, write it on the side. 1 prime times 2 plus 1 times 2 prime. So, 1 prime. What is the derivative of x?
1.
Very good. Times e to 4x. So I have this done. Plus, I copy x, the derivative of e to 4x.
Or e to the 4x.
Yes, e to 4x times the inner function prime. It's fine. 4 times e to 4x. Any questions on this, or we continue? Is this okay? Okay, what do you think I'm going to do next?
Combine terms.
They are not like terms. What would you do next? Without which we can continue. What is the only thing you can do here? Whenever we cannot combine like terms, what do you...
Simplify it.
How? If we cannot combine like terms, what is the other thing that we always think of doing?
Would it be factoring?
Please, yes, thank you, Sarah. What? Of course, yes, thank you. What?
You're factoring out the e for x.
Excellent. And I get 4x plus 1. Excellent. Now I'm asking myself two things. Does this equation have solutions? And the second is f prime undefined? Because I'm looking for critical numbers. Is f prime ever undefined?
No.
No. Absolutely. 4x plus 1 is polynomial. E to 4x is never 0. And it's always defined. So, good. Now, what about this equation? Do we get any solutions from that? From setting this equal to 0?
Yes, we do.
Yes.
Yes. How much is x?
Would it be 1?
1.
Okay.
No, 1. It's going to be 1 times 1 is 1. Different.
Okay, so it's not clear.
No, it is. I just don't know how to multiply instead of add. It's 1. Because it would be 1.
E to 4x times
1.
4x plus 1 equals 0. There are two possibilities by the zero product principle. E to 4x could never be 0. We know the graph of e to 4x is this. That's not possible. It never touches the x-axis. And the other option is 4x plus 1 to be 0. We move 1, we divide by 4 because this is a linear equation. So we get negative 1/4. So this is the only critical number. Now the question is, in part 2, is this critical number going to turn into a max or min? I have no idea. So here's what we discover, how we discover that. X can be anything from negative infinity to infinity. We established that. You told me carefully and clearly that it's a friendly function, no headache. Then we have f prime as the first row in line or next in line, and then f of x as the next row. All I care about is negative 1/4. I don't care about anything else. And here's 0. How come? Well, that's how we got it. F prime of x is 0 when x is negative 1/4. That's how we got negative 1/4, a critical number. Now I would like to study the sign of the derivative here and here. But how do I do that? Very easy. So look at the function, which is the derivative. Let me push my device further. So let's take a look at the first derivative. What type of number is this? Always. Look at the graph.
Positive.
Always positive. So I don't really care to even look at it. It's always positive. Forget it. If it's always positive, it will not change the sign. Now please plug in, let's say, negative 10 in here and just tell me the sign.
Negative.
Very good. And let's say plug in 0 on this side and tell me the sign.
Positive.
Positive. Okay, now we have to plug this number in the function. In the original function, of course. So